right, hey everyone. Welcome to this session. We're going to be talking today about security best practices for our serverless applications. Just as a quick introduction, my name is Higgy Park. I am a solutions architect here at AWS. I've been here about 9+ years. I spent a lot of my time here at AWS focusing on serverless, and more lately spending a lot of time with agentic applications.
Thanks, Higgy. My name is Chris McPeak. I'm also a solutions architect here at AWS. Been here about 7.5 years. Really focused on serverless application development and working a lot with our serverless teams. So we're going to be diving into this topic today around security best practices for serverless apps. Now, if you've never been in a silent session before, these can get a little bit weird, right? It's hard for you to hear me through headphones versus over a speaker. We like to get feedback, so head nods and thumbs up if something's resonating. Definitely appreciate. But I want to do something a little bit different this morning or this afternoon. On the count of 3, I would love everybody just to cheer. That helps me. That also tells everybody else you all chose the right session. Okay. Ready? So we're going to do this together. Ready? 1, 2, 3. Thank you. Awesome. Okay. So as we dive into this, I'm going to start off and go into a little bit of a survey of some different security practices for serverless applications, some foundation items that we need to really kind of talk through to get started. And then I'm going to have Higgy come back up, and he's going to dive deeper into some specific use cases, especially around some of the more modern application development that we've been working on, especially with agentic AI and some of the identity awareness that we need to think about with serverless security. Now, to help us out, what we're going to do is kind of frame this in the idea of a fitness tracker. Because I think sometimes it's a little bit hard to get our head around security without having an actual application to talk through or an architecture to talk through. So we're going to use this idea of having a fitness tracker. And the basic architecture that we're going to work with is we're going to have our athlete. I love cycling. I've done a lot of cycling in the past. As you can tell, though, I haven't been cycling a lot recently. So instead, we're going to use Higgy. Higgy is training for a marathon right now. Actually ran a marathon last week and loves using fitness trackers and collecting all of his data and figuring out how he's doing with running. So we're going to have this basic architecture. So an API that's going to collect that data from our tracker. That's going to feed into an API gateway. From that API gateway, we'll trigger a Lambda function that's just going to take that data and write it to a DynamoDB table. So as we go through and talk about security, we'll be talking about some of the security that you need to consider on each of the different layers of this application. Okay. So the first thing that we need to talk about actually is account boundaries. Now I realize this isn't necessarily a serverless concept, but it is something important to consider as we're developing applications. How many of you in the audience are developers? Awesome. How many are security engineers or focused on compliance? Great. So as developers, we love to move fast. We love to build very quickly. Oftentimes we'll have access to a sandbox environment where we can develop quickly, run our tests, and move fast. But this can pose some risks to a production environment when we're deploying directly into that account. So by creating these account boundaries, that actually allows us then to separate those areas of control so that you as a developer can move fast and test and develop. And then as you're deploying out to production, then you can have a structured deployment pipeline where as a developer, you can commit your code and it will run those automated tests and deploy that out to production for you. So that's a really important sort of distinction between accounts that just helps provide a good separation of concerns. Encryption, we all love to talk about encryption, and it's very important for us to consider. With AWS serverless services, a lot of security is already built in for you. But there are some things to consider as you're using some of the different services. So for example, if you're using Lambda functions, one thing that you'll want to think about is your environment variables and whether or not you're storing data in environment variables that needs to be encrypted. And you can use a KMS key to actually encrypt those environment variables and keep them safe. If you're using API Gateway and using a caching feature with API Gateway, again, you want to make sure that the cache is actually encrypted, and API Gateway gives you the ability to turn that on. So for each of the different serverless services, those are available. Some have the option to use just an AWS KMS key, and in some cases, you can also use a customer managed key to encrypt that as well. Now, all of the serverless services do have encryption in transit by default. So we manage that for you. API Gateway only accepts HTTPS requests. So you can't even accidentally create an HTTP endpoint that doesn't run encryption on API Gateway. Okay, the next area that we need to think through is IAM. So identity and access management, very important. As you're building serverless applications, that control plane where you're making API calls to AWS to make changes to Lambda functions or access different services is one plane to think about making sure is secure. And the other is the data plane. So this is where your application is calling different services and your application is running. And so there are a couple of different tools in IAM that we'll go through to consider as you're building out your applications. The first is at an organization level, and I'll dive into this a little bit deeper in a moment. AWS organizations policies or SCPs are going to be scoped at an organization level that can be applied across multiple accounts. Versus resource policies are going to be policies that you're going to apply to a specific service. And so that will control access to that specific service. So as you start digging into IAM policies at different layers, there are different areas that you can protect. So when we think about our architecture for our activity API, controlling what APIs are being called and how API Gateway is invoking our Lambda function, we'll want to make sure that we bound those permissions very closely. Okay, so with Lambda functions, specifically, I want to talk a little bit about resource-based policies versus the execution role of that service. So this is a little bit different than how you might consider security for maybe an application running on an EC2 instance. So with Lambda functions, you have two different policies that you're going to work with. That resource-based policy is what gets applied for any service that's triggering or invoking your Lambda function. There's a couple of other services that also follow this pattern, such as EventBridge. And so you'll want to make sure that you think through that resource-based policy for what services can invoke that Lambda function. Now, the execution role is on the other side of the Lambda function. That's the policy that's controlling what that Lambda function has access to as it's executing. So maybe it's a DynamoDB table, as we mentioned before in our architecture. So that gives you a different policy to control what that Lambda function is accessing. So for example, based on our application that we're working with, maybe that API gateway, we want to give it access to invoke our Lambda function as those activities are coming in and need to be processed. So we'll create a resource-based policy to do that. But we'll also give it that execution role so the Lambda function can write those activities out to DynamoDB. Okay, another concept that's really important that maybe as developers we don't always think about, but is a really foundational idea is around least privileges. Now, I don't know about you all, but this was a little bit hard for me to get my head around as a developer because I like to move fast, I like to try things, and sometimes it's just easy to scope something very wide open. But for those that are security folks in the room, I can already see the cringing, right, with having wide open policies. So least privilege is very important as you're developing in the cloud. You want to make sure that you're scoping those policies down to only the actions that that service is allowed to take. So if you think about your resource policies or your execution policies, you want not give it a wildcard star, but instead give it only the API actions that it's allowed to take. Now we can think about this in a little bit of an iterative way as we're developing as well, where we're setting permissions, running tests, verifying actions, and we can all do this in our pipelines as well to verify that we have permissions set well to meet the compliance for our organization. Now, the other side of that is, as a developer, I might want to set the policies for my services wide open, right? We already talked about least privilege there. Least privilege also matters for me as a developer. So making sure that I don't have access to things I shouldn't, or I can't take actions that might cause problems down the road or open up issues down the road. And so one way that you can handle this is by actually empowering your developers to create the policies they need, but also use permission boundaries applied to that developer that actually limits the scope of what they can open up. And so you can actually set specific actions to deny or allow on those permission boundaries. No allow, just deny, so that you're limiting what a developer actually can do in their account. Now, this is going to be a little bit different than the SCP roles, SCP policies that I mentioned before, where SCPs are organizational wide. A permission boundary is going to be just scoped for that role specifically. So let's take a little bit of an example here. So for our activities API that I talked about before, maybe I want full access to all the Lambda APIs, full access to Dynamo, and API gateway. I set a policy for any get actions so I can see what my API gateway is. But my security team really doesn't like that. They want me to scope that down a little bit further. They can actually put a permission boundary in place that only gives me access to Lambda invoke function and DynamoDB update item and API gateway put method. So you can see effectively when I bring these two permission boundaries and the policy that I put in place together, the actual effective permissions is just Lambda invoke function and DynamoDB update table. So even though I've given myself some wildcard policies to permissions to move fast, using that permission boundary actually scopes what I have access to down very tightly. Okay, so let's go back to SCP again and talk about this a little bit more. Usually when you get to an enterprise level organization that's doing a lot of serverless application development, a lot of times we don't want to have to apply specific controls at every single role. Maybe there are some policies for compliance that we want to apply across our organization, across all of the accounts that we actually have. And so using SCPs, you can actually apply these policies across the entire organization. So this just limits the scope that any of those policies might have access to. Now to help, let's talk through maybe an example of something that could be helpful. In our case, we have that API gateway sitting out front, and maybe what we want to do is we want to limit access to that API gateway from the public side. We don't want to create a public API endpoint. So what we can do is we can actually just allow private endpoints using SCP. So as any of our developers create an API gateway, they can only create it as a private endpoint, not a public endpoint. Now maybe to make this a little bit more real, let's talk a little bit about a different scenario. So in this case, we want any of the traffic coming from those trackers to actually flow through a different VPC, because in this case, maybe we want to run some security validation, or we want to route traffic a certain direction within our AWS network. And so what we can do is lock down that public API access so that we can then just create a private API endpoint and stick it in its own VPC. Then as traffic is coming in, it's going to flow through that broader VPC. Maybe we do some security analysis on that traffic. We'll create ENIs, in that account, in that VPC, that then allow traffic to flow into our API gateway VPC on the back end. So that just provides a little bit more security for our API endpoints if we have a need to actually flow traffic through VPCs. Okay, last sort of foundational area to think about API integrations. So I'm not going to talk too much about API integrations because Higgy's going to talk through some of that in a few minutes. But databases is also an important area. Now, in our case, DynamoDB table. And DynamoDB supports IAM. So I can give access to that Lambda function using an IAM policy to access that DynamoDB table. But what if my database doesn't necessarily support IAM? Maybe it's a database that I'm just running maybe on an EC2 instance. So in that case, you might think about using something like managed secrets. But the last thing you want to do is take those secrets and actually apply them in, hard code them in your code, right? So that's where Secrets Manager is a good place to store those and have your Lambda function actually access that Secrets Manager to be able to access your database. Okay, a couple of other areas just to think about as an organization. If we think about the development lifecycle and all the different stages that we have in the development lifecycle, there's a number of different security things to just keep in mind. Whether it's how you're authoring your applications and where you're storing that code, making sure you have least privilege permissions there, or even pushing code into repositories to trigger your pipelines, making sure you have IAM scoped down so that your pipelines are only deploying code from the right people. Another area that's really important to think about is just analyzing that source code, looking for maybe dependencies that have come in that were applied that maybe have some security issues in them. Amazon Inspector is a good way to do that, to have Amazon Inspector look at your code and provide any of those dependency issues that maybe have crept in. But I will say, if you Matt Garman's keynote this morning, he actually the agent. We didn't even know that was available then. Did everybody still? My mic is cutting out sometimes. Okay, we'll have our folks in the background. I'll keep talking and they'll check on it. Okay, so Matt Garman this morning talked about a security agent that we recently released. This is also a really good tool to make use of to analyze your source code. Okay, so another possible scenario is, let's say you weren't inspecting your code and you allowed a dependency to be applied in your application that got through some of your testing. So in this case, you might want to look for application anomalies to detect that maybe that dependency got through. And so at a runtime, Amazon GuardDuty can look at your VPC flow logs as a way to detect any anomalies that are maybe happening in your application because something was missed earlier on. Okay, event payloads. Another important area to consider as you're thinking about security. So with event payloads in Lambda, there's actually a really good tool out there called Power Tools that makes it really easy for you to add things like strict typing to validate that input as it's coming through. So you can see here, this is just a brief example where we're importing that Power Tools dependency, and that's going to actually help us to validate very easily in Lambda. There's some really good Power Tools sessions going on this week. There's a team at AWS now that's actually developing that and owns that for us. So I definitely encourage you to take a look at that. But what if we could also look at those payloads before they come to Lambda and look for maybe differences in schema before a request actually comes in. And so within API Gateway, we can validate that input, do input validation, make sure we're getting what we expect to get from a schema perspective before we pass it on to that Lambda function to actually run. So three available configurations. So you can look at the body, you can look at query string parameters, make sure they're what you expect, or you can look at all of the above to validate that event that's coming through. Okay, last couple sort of foundational items, protecting your API endpoints. So before we talked a little bit about taking our endpoints and making them private. Another tool that you have access to is AWS WAF. This gives you the ability to protect those endpoints based on IP addresses, based on geographic regions that you might want to limit access to that API gateway. AWS WAF also has the ability to take in rule sets from third parties. So this is a really helpful way to have a subscription applied that will actually protect those endpoints based on what's being seen out in the wild. If you go on the AWS Marketplace, there's a number of providers that will provide that subscription for you into AWS WAF. So those are some really good ways of protecting your endpoints using an outside tool like WAF. But now I'm going to hand it over to Higgy, who's going to dive into some identity-aware applications.
Cool. Thank you, Chris. Can you guys hear me? All right, sweet. So Chris gave us a really good broad spectrum of a lot of different things that we need to be thinking about as we're building our serverless applications. What I'm going to do is, over the next maybe 15, 20 minutes, we're going to actually dive really deep on one particular kind of application stack security consideration, which I'm seeing as a very common use case, especially as we start to think about both serverless applications, but also agentic applications, which is a common thing that I see a lot of my customers starting to think about. So we're going to go back to the application that Chris presented before. Again, we have our fitness web application. So this is the first component that the user is going to be interacting with. Of course, that web application is going to then interact with our serverless API gateway. This is going to be the activities, routes, et cetera, those APIs. And then, of course, the business logic will reside within our Lambda function. So a bunch of what Chris talked about already is going to be these resource policies, execution roles, perhaps even those SCPs for doing deployments. The part that I'm going to spend a bunch of my time on is going to actually be here on the left side, thinking about user authentication, authorization. How do we make sure that the user, so let's say Higgy is interacting with this fitness application, is doing things that he is allowed to do and is accessing resources that I am allowed to access, okay? So before we get into that, let's take a quick look at our serverless application. So this is our the one that Chris had introduced before. And again, we have these different API endpoints that he had introduced before. The thing to notice that, again, Chris had talked about was we have a number of different of these APIs that, again, you can think about as the architects in the room. We're using like domain-driven design, and these are some bounded contexts. These are the domains of logic. So you can imagine different teams are provisioning these different APIs, and maybe they have different auth schemes. And we're going to get into that momentarily. The key thing that a lot of organizations will do when they're protecting these type of API endpoints is going to be using a standard called OAuth 2. And we're going to dive pretty deep into OAuth 2. But before we do, why don't we go over a couple of the terminology that we're going to be using throughout the rest of this talk. So when we think about OAuth 2, there are a number of different entities that we want to be aware of. So the first is the owner of that resource. So you can imagine maybe there's some amount of data we are trying to protect. And let's say Higgy, again, maybe I'm a Strava user, I really like to run. So I have some of my data in this service, and in theory, I own the data, or I should be the one that grants access to that data. I then use maybe a web browser, maybe a mobile client. In this example, we'll just use a web browser. That is going to be the user agent. So that is the mechanism by which I'm going to be interacting with these protected resources. Then you have the web application. So my web browser, of course, connects to a particular web application. Maybe I have it deployed in Fargate. That web application or client then interacts with the API that we are trying to protect. So this is that serverless API that Chris was talking about before. And last but not least, of course, there's the authorization server, right? So we need some entity, some identity provider to be able to determine who is allowed to access these resources and what resources are they allowed to access, okay? So these are the 5 key kind of entities that we're going to be thinking about throughout this entire flow. Another thing that we want to think through is how do we actually get access to the resources? So there's some process by which this access is going to be granted. So there are actually a number of them. In this talk, we're just going to talk about 2. Really, we're going to talk about 1, and then we'll see how when you learn about 1, you've already learned about the second one. So the first one is authorization code or code authorization flow. And this is the most common one that probably you're familiar with. So you may be familiar with, like, when you click on a web page and it says, do you want to allow access to this particular application for these resources? That is an example of code authorization flow. The second one is client credentials flow. So where the first one is end user facing, so I'm logging into a web page and then I'm going to allow access. Client credentials is typically used in machine-to-machine communication. In the former, you have this user interactive experience where someone is going to be clicking, essentially allow. In a client credential scenario, you want a machine to be able to do that, so there is no user that's going to be clicking that approve or allow button. Okay, so these are 2 flows we're going to talk about. We're going to dive really deep in code authorization, and then you'll see how you've already learned about client credentials. Some other things that we want to think about. So the relevant credentials that you want to be aware of. So when you are creating an application, or maybe when you as a developer are building an application, you actually need to register that application with your identity provider. So the first thing that you end up creating is what we call the client ID. And perhaps the simplest way to think about it, it's not exactly like this, but you can almost think of this like a username. So me as an entity interacting within the system, maybe Higgy has a username that is associated with me. Well, for an application, you would have a client ID associated with that application. So when you register it with the identity provider, it will vend you a client ID. Next then is the client secret. And again, as you can imagine, this is somewhat similar to having a password. So a username password, but this would be essentially the client ID and client secret for the particular application. And these 2 together are used to then essentially authenticate that this is the application interacting with the identity provider. Okay? All right. One more set of tokens, and then we're going to kind of dive pretty deep into it, and then we're going to apply this to our serverless application, right? So these are a number of different tokens that you then get when you exchange your client ID and client secret and my user identity, right? So the first is an ID token. This is a short-lived token. The really simple way to think about this is this ID token identifies who is interacting with this service. So it might have information like my username, maybe my email. Again, this is all dependent on what you want to include in your application. The next is the access token, and this is perhaps the one that is most important. This is the one that defines you've authenticated. Now this defines what are the actions that you are allowed to take. So we call these scopes. This will say I'm allowed to have read access to this particular endpoint. Maybe I have write access to this particular endpoint. And then last but not least is what we call the refresh token. So you can imagine in the code authorization flow, as a user interacting with it, it might be painful to every 15 minutes or every 60 minutes to ask that user to reapprove that request. Well, the refresh token is then used to actually do that automatically. So this may be a longer lived credential. Maybe we're going to allow this credential to live for 24 hours, and we'll refresh the user's tokens by using this refresh token. Okay, so these are the credentials, tokens, and some of the identities within it. So these are all the components necessary when you're building serverless applications, or as we show in a little bit, we're going to see how this is going to be used for your agentic applications as well. Thank you, thank you. All right, so the first phase, I'm going to talk about 2 phases. So for the code authorization flow, there's really 2 phases. And in this first phase, really what you want to think about it is the user is essentially logging in and getting an authorization code, right? And so you have this user, so Higgy, I'm going to log into the web browser. You can imagine I'm going to get redirected to a login page, right? And so again, this is probably familiar with all of you. After I log in, then you get that little that pop-up that says, do you want to allow Higgy access to this particular resource? And it'll have a bunch of checkboxes. We're going to go ahead and hit approve. Once you hit approve, what happens on the back end is the identity provider will generate an auth code. And so this is just basically a long string. It's a one-time use string. It then sends that back to the front end. So the front end application receives this auth code. It already had the client ID and client secret. So again, this is something that you registered with your identity provider when you created the application. When you now deploy the application, that gets deployed alongside with the application. So now the application has the client's ID, client secret, that it uses to authenticate with the identity provider. It now has the auth code, which is now user-specific, and it uses that to then exchange for a set of tokens. So this is the first phase that is user interactive. Now the second phase is, okay, so we had this front-end application. It was deployed with that client ID and secret. It just received that auth code, that exchange that we just did. It is now going to go to my authorization server. In this case, I'm going to use Amazon Cognito. And it sends the client ID, the client secret, and that auth code. And when Cognito will then validate these strings and credentials, it will then provide back the ID token, access token, and refresh token to the front-end application. The one thing that I want to stress here is as you're building your serverless applications, you are not going to expose these ID tokens, access tokens, and refresh tokens to the web browser. You want to make sure these stay within the bounds of the front-end application. These are not things that your end users should actually end up seeing. This is all happening in the back end. So what happens is you'll send, let's say, the ID token with API Gateway. That goes to the authorizer. API Gateway will then take that ID token, go back to the authorization server, and go and validate, is this a valid ID token? So again, it'll go in and say, okay, I see this is an ID token from Higgy. He wants to then go and access the backend API. API Gateway, once it receives that validation, it sees, okay, this is an allowed request. It will then, oops, I guess I didn't have it in there. It will then allow it to, let's say, invoke the Lambda function on the back end. And as Chris had talked about before, this assumes then you had already configured, let's say, a resource-based policy with your Lambda function so that API Gateway is allowed to actually invoke it. Okay, so we talked about phase one is with that the end user interaction. Phase two is on the back end where you have again, the client application, the front end application, doing a bunch of these token exchanges. The reason we break this up into, actually, I think I'm skipping ahead here. So this is actually a quick a refresh of the whole flow. So user comes in, connects to the front end application, logs in, gets the auth code, sends it back to the front end application. It then validates that, invokes the API. The API gateway will check with the authorization server, and then here's where we have that Lambda function that then gets invoked with that resource server. So what's nice here then is within Lambda, again, for those folks that have built with Lambda functions, how many of you guys have deployed a production application using Lambda? Okay, a lot of you folks. So you know with your Lambda functions, with your handler, you have two parameters there. One is your event payload, and then one is your context payload. So you can actually see within the context payload a bunch of identity information. So this could be something where maybe as a developer, you know that this was an authorized request, but maybe there's some additional things that you may want to do within your business logic. Maybe you have like a grouping of users, and based on certain entitlements, you want to allow them to do certain custom actions. This is something you could then custom code into your Lambda functions. So this is a lot of additional information you have available to you even after you've already done the OAuth flow. So what I was getting at before is we talked about phase one and phase two. Phase one is the user interaction. Phase two is that machine to machine. Well, with client credential flow, you could essentially strip off phase one, that login piece, and the exchange for that auth token. And now for client credentials, it's just phase two. So you've now basically learned both. So here you see that web application. It gets deployed with the client ID and client secret. Now it just exchanges the client ID and client secret for that set of tokens, that ID, access, and refresh token. In this scenario, we no longer need the auth code because this is not interacting with any particular user. So again, now we just do that same flow. We send maybe that bearer token along to API Gateway. It then goes and validates with your identity provider and then invokes your Lambda function. So you're kind of asking like, okay, that was a lot to try to understand OAuth 2. Well, with a lot of both serverless APIs and also with a lot of agentic applications, OAuth 2 is the foundation security mechanism for ensuring that users have access to the appropriate downstream resources. So for folks that are building serverless APIs, or if you're thinking about even building agentic applications, this is going to be a core flow that you're going to want to understand, and we're going to talk about how we make this a little bit easier for you in the next couple slides. So we covered OAuth, but what about, are there other ways for your serverless APIs to think about doing the same type of mechanisms for fine-grained permissions? Well, there is. So you can also do something with Amazon Verified Permissions. So similar flow, you have an end user coming in, they're going to authenticate with the identity provider. You will then try to access, so I cut out the client because you can just assume it goes through. You're going to then try to access your API gateway endpoint. And here you're going to include that token as a bearer token within the header. And in this case, with API gateway, you can actually use now a Lambda authorizer. So you can configure an authorizer to then interact with our verified permissions service, right? So you can actually take the header, whatever that token might be, and then it will then go and do a verification. So here's the token that comes in, run it against Amazon Verified Permissions. Amazon Verified Permissions will then come back and say allow or deny. And then based on that, we'll then perhaps invoke the backend if that was allowed. Now you may be asking, like, how do we know, or how do we actually define, like, who's allowed to do what? Great question. So with verified permissions, what it actually does is it actually uses a policy language on the backend, and this is actually an open source policy language called Cedar. Here's a little bit of what that might look like. So this is an example. So maybe for the security folks, I saw when Chris was asking before, there was maybe a third or maybe even a half of this audience, you're really focused on the security side of things. You can actually, using code, define the allowed actions for a particular set of resources. So here's an example where perhaps we have a particular namespace. So I want to include, so here at reInvent, we have a bunch of APIs that are defined for demos here at reInvent. There's actually also a group of users. So maybe the audience here in this particular session is going to be included as part of this permission. And then this is then the Cognito user pool, along with the Cognito user group. Right? So this is the principle. This is the allowed identity that is going to be defined by this particular policy. And then this then is the allowed action. So the audience here, if you were to make a request to my particular API that uses this Lambda authorizer, will be allowed to make a GET request to the /products API endpoint, or maybe the /activities API endpoint. So this is an example of a policy I can define using Cedar. I would then essentially configure verified permissions to then use this policy when API Gateway makes these type of requests. Okay. So a number of different ways. We talked about OAuth in depth. We talked about using verified permissions to be able to identify users that are coming in, make sure we have these identity-aware interactions with my serverless APIs. So let's try to push the boundaries a little bit and think about, is there a way we can continue to innovate from a security perspective in where we're seeing a lot of new applications being built? So coming back to our serverless fitness application, we have our traditional application. We have, again, our different API endpoints. So one thing that we may want to think about, and you may have heard about some of this, again, even in the keynote this morning, Matt Gardman was talking a little bit about using and building agents. And so one way we can think about maybe transitioning our serverless fitness application into an agent application is using something called tool calling. Right? So within our agents, now we're going to build this agent using an agentic framework. We have an ability to then create and define what we call tools. The simplest way to think about this is a tool is just another function that we're going to annotate as a tool, and we're going to then call our different serverless APIs. So the activities, route, socials, and support API that we already have for our serverless fitness application, we're just going to essentially wrap it in a function and annotate it as a tool. The nice thing then here, so these are the tools that we're going to be able to create. The nice thing then here is that our agentic application here, as it interacts with a model, an LLM, it is able to very easily gain access to the data that is accessible from these different APIs. So you can imagine maybe Higgy as a runner. I just did, let's say for the last 30 days, I did 10 runs over that period of time, and I actually want to do a little bit of analysis. I want to try to understand, what is my average heart rate over this period of time for a particular weather condition? And am I actually improving in my fitness, or am I actually getting worse? Is there something that I need to change in that? So this is certainly something that in a serverless application, I can go and build and write imperative code to be able to do this. But maybe as a developer, maybe there's a simpler way to do this, and maybe I can actually leverage an agent application to be able to do that on my behalf. And this is perhaps where some of the ideation can come and why we may want to actually move into this direction. Okay, so thinking about tool calling, then you may be thinking, okay, do I have to like wrap a lot of my APIs and do a bunch of work in order to be able to bring this API data into my agent? Well, fortunately, we've actually created, or we didn't create, Anthropic created an open specification last year, and you may have heard of it. Anyone ever heard of the acronym MCP? MCP, so number of handfuls. So MCP stands for Model Context Protocol. It is basically a specification that, that standardizes the way that you do tool calling within an agentic application, right? So this is where you can now, as your fitness agent, can essentially have a singular MCP client, and now the different data providers can then provide an MCP server, right? And so again, you can imagine with the activities, routes, socials, and support APIs, maybe those are actually by different development teams within your organization. So you can imagine team A is doing the activities API, team B is doing the routes API, et cetera. So each of those teams as data providers or as API providers would be responsible for vending an MCP server. Now, you may be asking, okay, what does this all have to do with the security talk that we're really focused on here? Well, in this whole process, there continue to be security considerations. So here's an example where all of that OAuth 2 stuff that we just talked about and learned, we're going to apply that into this agentic application. So you could imagine, as an end user interacting with an agent, maybe there's the code authorization flow, right? And so again, as an end user, maybe I'm accessing this through a web browser. I'm going to log in, and then I'm going to click authorize, and now I have access to this fitness agent. You can imagine then, I asked that question that I asked before of like, help me understand the last 30 days of running. Can you do an analysis on my data? Am I improving? Do I need to change something in the way that I'm training? The fitness agent will then make a determination and say, actually, go make a call to our activities tool, which will use the MCP client and talk to the MCP server. So again, because this is a machine-to-machine communication, maybe we've configured client credentials to allow my agent to be able to talk to this MCP server. But that's actually not the last step. The MCP server itself is going to then talk to my serverless API, right? And so maybe we have a setup here where we're going to also use client credentials because this is also a machine-to-machine communication. You may also want to think, actually, I want to make sure I'm propagating identity information from Higgy as the end user accessing the agent all the way down to the activities API. So maybe instead of a client credentials, maybe we actually want to use the code authorization flow. And for the astute in the audience, you're probably thinking, how do you do that? My MCP server and activities API is way far in the back end. How do I actually propagate that end user request? Well, there is a way you can actually stream that request back all the way to the front end so that I, as a user, can actually hit the accept button. Okay, so we talked a little bit about, we have our serverless fitness application. We're thinking maybe this is an opportunity to build an agentic application. We spent a bunch of time on the OAuth 2 flow. We talked about Amazon verified permissions. This is a lot of security stuff that we want to think through. Is there perhaps a simpler way that we can do this? There is a simpler way, or perhaps an alternate way to do this. So again, in our session, in the keynote earlier today, there was a bunch of announcements around Agent Core. So there are a couple of services to actually make this simpler. So Agent Core Runtime is a serverless runtime similar to Lambda, similar to even to Fargate, to be able to run your agent applications. On top of that is then something called Agent Core Gateway. Similar to API Gateway, where API Gateway is the front door for all of your API front ends, we think of Agent Core Gateway as the front end for all of your tools that you're going to then expose to your agent applications. There are a number of managed tools that you have available to you. So again, browser, if you want your agents to be able to go and do research on the internet, maybe you want to hit other websites to be able to glean information about the particular query that the user is coming in, you could use Agent Core Browser. Code interpreter is a situation where maybe your agent is actually going to be generating code on your behalf. And this is untrusted code. You don't want to actually run this within the context of perhaps your enterprise. You want this code to actually be isolated. And this is where you might actually use something like Agent Core Code Interpreter. where we'll spend a little bit of time in the next slide is Agent Core Identity, where we think about all of these OAuth considerations, all of these security considerations in this auth flow, and is there a way that we could actually make it simpler? And Agent Core Identity aims to make that process simpler, and we're going to dive into the next slide. There's also Agent Core Memory. So in your experiences with different agent applications, one of the key experience benefits that we've seen customers wanting out of these applications is this personalized experience. So this desire to see, hey, it actually remembers that this is Higgy interacting with this fitness application and remembering even some of the last queries about the particular application. So memory will allow you to do some of that. And then, of course, there's observability. So observability will allow you to understand the full flow of the actions that are happening within this particular application. It will also give you an idea of the type of login activities and the tool calls that are being made with this application. But again, let's talk a little bit more about identity and how we can actually apply some of the OAuth flows in this agentic application in a simpler way. So before we talked, again, about maybe there's the user, maybe there's the interacting through the web browser, and now we want to actually interact with this particular agent. So on the front end side, there's something what we call inbound authorization, auth. And the idea here is if this is an application perhaps running on an EC2 instance, maybe it's actually being invoked by a Lambda function, we could probably use something like IAM. So IAM, you can then do all of the things that Chris was talking about before. So IAM basically defines what are the actions that this entity within AWS is allowed to do. So if there's an app running in EC2, in Fargate, or even in Lambda, that execution role would allow us to invoke this particular agent. Alternatively, if it's actually maybe external to your organization, this is not actually running in AWS, this is running in your own infrastructure, and you don't have an IAM role associated with that particular infrastructure, you're likely going to then use OAuth 2, which we went into in great depth. Then we have what we call outbound auth. And outbound auth is basically configured based on whatever the target might actually be. So if your agent is going to be accessing, let's say, an S3 bucket. So if your agent is going to try and go and extract additional information out of PDF documents in an S3 bucket, you'll just use an IAM role for that. So similar to what Chris was talking about before, depending on what you're going to be accessing is what you're going to actually end up using. So again, maybe an S3 bucket, maybe a Dynamo table, maybe something else within your AWS account. This is where you'll use an IAM role for your outbound auth. Otherwise, for anything else, you're going to end up using OAuth 2. And this is why we spend a bunch of time on that OAuth flow to really help you understand when are you going to be using those different flows. So if you have an end user interacting with a particular protected endpoint, that's likely where you're going to be using the code authorization flow. And then if this is machine-to-machine communication, you're likely going to be using something like the client credentials flow. OK, so why don't we have a couple, I guess, key takeaways from this talk. So the first thing one of the things that Chris talked about here is, again, implementing least privilege policies. So if ever you're writing a policy in your AWS account and there is a star there in your policy document, it should give you pause and think, should I really be doing this? Now, that said, there are some policies that do require star. And so in that scenario, sure, that is OK. But if you're going to be accessing a particular Dynamo table or a particular S3 bucket, you want to be as explicit in the resource, and you want to be as explicit in the particular actions that you're allowing in that policy. So again, least privilege policies. Defense in depth. So Chris talked through a lot of different ideas in how you can actually secure your serverless applications. The idea here being, don't just apply one or two of these, apply as many as possible. So you're going to use IAM execution roles. You're going to use your resource-based policies. You're going to use WAF to protect your public endpoints. You're going to use SCPs to make sure that developers aren't deploying resources that don't comply with organizational policies. So there's a lot of different mechanisms that you as an organization can apply to ensure that you have a secure serverless application deployed. Leverage the deep integrations across AWS. And so one of the beautiful things around building serverless applications, whether these are synchronous APIs or what we didn't spend a lot of time on is like async event-driven patterns, the fact that AWS will manage those integrations on your behalf, and a lot of times you're going to configure IAM roles or resource-based policies, create those least privilege policies and let AWS do a lot of those integrations on your behalf. This helps kind of ease the burden of a lot of the undifferentiated heavy lifting of configuring these different integrations. And last automate these security protection mechanisms, right? So again, Chris talked about things like guard duty, so you can configure it so that you get runtime protection. In your CI/CD pipelines, as Chris talked about before, you can implement a bunch of these protections, whether you're on the developer machine, whether you're committing code to a repository and triggering your CI actions, or even as you're deploying into your environment, you want to make sure that all of these checks are being included as part of that deployment process. Okay. So I think that concludes. We have a number of other sessions that we want to recommend that you go take a look at. These are a bunch that are really relevant for as you're thinking about building and securing your serverless applications. There are a number of other resources that are available to you. So these are some serverless resources that we recommend you go check out. And with that, we want to say thank you for coming.